Hey friends, this is Anirudh. Welcome to my channel. So here we will be discussing a physics topic pertaining to the chapter of ray optics or geometrical optics. And this is one of the most important parts of this chapter. You can expect one question in this this topic in the Neet exam. You can expect one question from this topic in the Neet exam, and that is prism. Right. So let's proceed to the discussion of the chapter. So prism. Whenever we hear the term prism, it is a prism that is the geometrical structure that is coming to your mind. I know that whenever we hear a prism, the word prism, it is that particular structure which comes to your mind, that prism like structure which you have learned in your lower classes. But actually in terms of physics, in terms of optics, it need not be a structure that is actually given the name of prism for prism action to be present whenever light passes through it. So basically the word prism simply means that it is an arrangement where the incident surface and the refracting surface are not parallel. They should not be parallel and they can be present at an angle to each other. Once you have that particular condition fulfilled, you have prism action setting in, right. So if you consider I have a rectangular slab of glass, you have a rectangular slab of glass, and I say that an incident ray is incident on the surface, right. And if this is the normal, I say that it is moving from rarer medium to denser medium, it moves towards the normal, and here it is moving from denser medium to rarer medium, it moves away from the normal, isn't it? Now is this prism action? Here the incident surface is this and refracting surface is this, they are parallel, so this is not a prism action, right. Similarly, I have a sphere made up of glass into which I am just passing an incident ray, and this will pass through this and finally it will come out. Is this prism action? No, this is not prism action. Why? Because this is the surface which is incident surface and this is the refracting surface, right. So this incident surface and refracting surface are parallel in this case, so this is not a prism action. Whereas if I just lateralize this particular incident ray over here, I just move this particular incident ray to the side such that if I just talk about this particular condition, it moves again towards the normal, but it hits this particular surface, and now the normal is like this and it moves away from the normal, right. Now is this prism? Yes, because here the incident surface is this and the refracting surface is this, they are at an angle of 90 degree to each other. So this is equivalent to saying that I have a 90 degree prism, right. So that is how the whole concept of prism is coming into picture here. So prism is not just meaning that you need to have structure which is you need to have an instrument which is the actual prism. It is just that it is arrangement where the incident and refracting surfaces are not parallel but they are in an angle, at an angle to each other, right. So let's proceed to the deeper more topics. So if you consider this particular big prism I have drawn over here, these are the two normal, see 90 degree lines which are drawn to these particular surfaces. So this is the incident surface and this is the refracting surface, right. They are at an angle to each other and this angle is demarcated as A. Now what does A stands for? A is called as angle of prism. How will you define the angle of prism? Angle of prism is the angle of the incident surface and the refracting surface which makes it with one another. So the angle between incident surface and refracting surface is called as the angle of prism. Let us suppose a ray, incident ray is coming like this, isn't it? So this is how the incident ray is coming into the prism. The angle the incident ray makes with the normal is called as angle of incidence. I will be marking it as I1. Angle made by the incident ray with the normal is called as angle of incidence. I will be marking it as I1. This ray will be actually moving from rarer medium to denser medium, so it will be moving towards the normal, right. So it moves towards the normal, it crosses the entire length of prism and it reaches the other surface, and from this surface it is moving from denser medium to rarer medium, so it moves away from the normal. So this is the whole pattern of refraction that is taking place within the prism. When an incident light, it is an angle of I1 to the normal, right. Now this angle of emergence, you can write it as E, that is angle of emergence, but yes, I will be preferring to write it as I2 for the purpose of deriving many things and for the simplicity of learning every concept. I will be marking this as I2. I1 is the angle of incidence, I2 is the angle of emergence, right. Okay. Now what is this angle? The angle the refracted ray of the first surface is making with the normal of first surface. This is the angle of refraction. I will be marking it as R1. This is the angle, right? This is R2 of the refracted ray meeting the other surface. So this is the angle of the refracted ray within the prism which is making with the normal of the other surface. This is the normal of the other surface, that is called as R2, right? So that is all with respect to the angles. Now let's proceed to the further discussions where I will be talking about the deviation. See, incident ray is at an angle of phi1 to the normal, isn't it? Now had it been going in the same straight line, it will be going in this way, right? This particular emergent ray, if it was coming at this angle only, it will be coming at an inclination like this, right? So I know that the incident ray should have been going in this way, but now it is deviated to this side because of refraction, and we call this particular angle as the angle of deviation, delta 1, right? This is the angle of deviation at the first surface, and at this surface you see that the emergent ray is coming out in this direction. It should have been coming out from this particular direction only had there been no refracting surface, but due to refraction this is coming from this kind of an inclination, right? So here is the second angle of deviation. So the ray should have come in this way, but it is deviated to this side, isn't it? So this is the deviation, then that is marked as delta 2. Now what is the total deviation of the whole ray here? This is the total deviation that is studied as delta itself, right? So that is how we link all those concepts together. Now what we will do is that if you just make this triangle into consideration, if you just talk about this particular triangle that I am marking here, right, I know that delta is the exterior angle of this particular triangle, right? So this particular small triangle within this particular big triangle, the delta is outside this particular triangle, and delta can be written as exterior angle is equal to sum of two interior opposite angles. So delta is equal to delta 1 plus delta 2. What will I substitute for delta 1? See, I understand that I2 and delta 2 plus R2, see this particular whole angle and I2 are vertically opposite, so they are equal. So delta 2 plus R2 is equal to I2. So delta 2 is equal to I2 minus of R2. So that is I2 minus of R2, right? In place of delta 1, I1 and delta 1 plus R1, this big angle and I1 are vertically opposite. So delta 1 is equal to I1 minus of R1. So that is I1 minus of R1, right? I am just rearranging this. Delta is equal to I1 plus I2 minus of R1 plus R2, right? Let it remain as such over here. So this is the normal ray. The normal makes an angle of 90 degree with the refracting surface. We all know that, right? That is why it is called as normal ray. So this angle is 90 degree. Now, how much is this angle then? If the total angle is 90 degree, so this will be 90 minus of R2, that is equal to this angle. So this is 90 minus of R2, and this will be 90 minus of R1. Similarly, this will be 90 minus of R1. See, this is the total angle, that is 90 degree. 90 minus of this particular small angle will give you this particular big angle, that is 90 minus of R1. Now, consider triangle ABC. In triangle ABC, we can apply the angle sum property in the triangle. So I know that in triangle ABC, angle A plus 90 minus of R1 plus 90 minus of R2 is equal to 180 degree. We will write it here. A plus 90 minus of R1 plus 90 minus of R2, this is equal to 180 degree. Angle sum property of the triangle. 90 plus 90 is equal to 180 degree. This R1 plus R2 will go to the other side. So, we will get the first basic result, that is A is equal to R1 plus R2. The angle of prism is equal to the two angle of refraction when they are added to each other. Now, you will just plug in this particular value over here. So, you will get another important equation, that is delta is equal to I1 plus I2 minus of, in place of R1 plus R2 you are plugging in A, so that is A, right. So I1 plus I2 minus of A is the angle of deviation, the total angle of deviation which is present over here. Angle of deviation is the angle between the incident ray and emergent ray, right. Had the incident ray gone in this particular direction and had the emergent ray come in this particular direction, that particular angle is delta. That is the angle of deviation between incident ray and the emergent ray. So you have got two important equations as such, as the preliminary requirement of studying the more deeper concepts of prism, that is A is equal to R1 plus R2 and delta is equal to I1 plus I2 minus of A. Let us proceed to the further discussion. Next we will discuss the condition for no emergence. See, emergent ray is what comes out of this, and I need to prevent the emergence of that ray while I will be providing it with an incident ray. So this incident ray will be coming here at an angle of theta, or I can say it is coming at an angle of I1. That is what we are actually writing here, isn't it? Now this is equal to R1, this angle of refraction is equal to R1, here this incident angle is R2, and then comes the I2. But the point is, see, I2 should not come out, the emergent ray should not come out. Now how will I prevent it from coming out? Imagine that if R2 is greater than theta c, the critical angle for this particular surface. If it is more than the critical angle, now what is critical angle? The angle of incidence for which the emergent ray, the refracted ray grazes over the surface of the interface between the two medium. That means if R2 is equal to the critical angle, then my outside ray, that is emergent ray, will be going towards, it will be going through the interface. See, this is the border of the prism, it will be going through the border of the prism to the that side. And still if I increase my R2 more than equal to theta c, it simply means that my emergent ray will be coming out in this way. This is called as total internal reflection. So I have prevented it from going outside. I have prevented the emergent ray from going outside by increasing the R2 more than equal to the critical angle of the surface, right. So we will derive certain equations from this, certain very basic concept that I would like to tell you from this, right. So what I will do is that we will find the minimum R2 condition, minimum R2 which is more than equal to theta c. See, when I consider the minimum R2 condition, I know that R1 plus R2 is equal to A. A is a constant so far as I don't change the prism. A is a condition of the prism. See, A is a intrinsic property of the prism. So A is equal to R1 plus R2. As R2 decreases, to maintain A as a constant, R1 will have to increase. So as R2 increases, to maintain A as a constant, R1 will have to increase. So R1 will increase, right. When R1 is going to increase, you know, here I can apply the Snell's law. I know that sin I1 is equal to mu sin R1, where mu is the refractive index of the medium of the prism, right. So if R increases, then the LHS will also increase. So sin I1 will increase, that means I1 is also going to increase. What is the maximum possible value of I1? Maximum possible value of I1 is when it comes through the surface, that is 90 degree is the maximum possible value of I1. It cannot go beyond that, right. Normal is at an angle of 90 degree with the surface of the prism, and I am sending a wave, I am sending a light through the surface of prism. So maximum possible I1 value is equal to pi by 2, that is 90 degree. When the maximum possible value of I1 is equal to 90 degree, then R1 is equal to theta c, isn't it? If I1 is the maximum, that is 90 degree, if it is grazing over the surface, then R1 is equal to theta c. So I get that R1 is equal to theta c, and you have R2 is more than theta c. If I add R1 plus R2, see, R1 is theta c, R2 is more than that. So adding something with more than something will give you more than that itself, will be more than 2 theta c, right. Because R2 is more than that and R1 is this, you will get R1 plus R2 is equal to more than 2 theta c. Common sense is applied over here, right. So R1 plus R2 is equal to A is greater than 2 theta c. So A is more than 2 theta c, that means I will just use the properties of inequality here. A by 2 is more than theta c. If I take the sign values over there, sin A by 2 is more than, what is sin theta c here? You know that if I just consider this refracting condition and if I say that this is equal to theta c, then my refracted ray will graze over the surface of the interface between the two medium. I am applying Snell's law over here in this kind of a condition. Sin theta c is equal to, right, mu sin theta c, this is the refractive index of the denser medium, is equal to 1 if this is air. Let us suppose this is air and this is water itself. Water mu is equal to 4 by 3, we all know that. And this is 1 sin 90 degree, right. Sin 90 is equal to 1. So, sin theta c is equal to 1 divided by the refractive index of the medium. So, this is the simple derivation that you make whenever you learn the concept of total internal reflection, which is an exaggerated condition of refraction as such. So, sin a by 2 is equal to, is more than 1 by mu. So, if you just rearrange this, you just take the reciprocal of that and you will get it as mu, which is greater, mu is greater than cosec a by 2. So, this is the condition for no emergence, right. So, these are the two important equations you need to remember for the purpose of learning the condition for no emergence. That is, 1, A is equal to, A is more than twice the angle of critical angle towards the surface, and second equation is that the refractive index of this particular medium of the prism, if it is made up of glass, the refractive index of glass should be more than cosec a by 2, where a is the angle of the prism. What is angle of prism? Angle between the incident and refracting surfaces of the prism, right. So, mu greater than cosec a by 2 is a very important equation so far as this condition of no emergence is concerned.